Hi, my name is Dennis Jin, registration number UR14CS319, and I am here today to explain the sixth experiment of DBMS, which is the creation of other database objects. And our aim here is to manipulate the scheme objects for the given furniture company database using views, index, and sequence. So what is a view? A view is technically like a virtual table that's based on the result set of an SQL statement. A view contains rows and columns, just like a real table. The fields in a view are fields from one or more real tables in a database. You can also add SQL functions where and join statements to view a view to a view and present the data as if the data were coming from a single table. So our first question here is to create a view to display the customer name, order ID, and quantity. So to do that, our syntax is to create view 1 as select customer name, order ID, order quantity from customer order quantity. So what this does is it creates a view named view 1 from the rows customer name, order ID, order quantity from the tables customer and order quantity. So we have an output saying view is created, and select star from v1 would display the given table. After that we have our create materialized view, v1 build immediate refresh force on demand as select customer name, order ID, order quantity from customer order quantity. So what a materialized view in database is that it's basically it's also a logical view of our data, but the result of the query will get stored in the table or a disk. So to create, so that's the syntax to create a materialized view, and our table is displayed here. Our second question is to create a view to display the order ID, order date, and date of delivery. So our syntax is to create view 2 as select order ID, order date, as date from order and suppliers. So this would create a view consisting of rows from these two tables with these rows. Right, so that would give us this output here. And to create a materialized view, our syntax is to create materialized view v22 build immediate refresh force on demand as select order ID, order date, as date from order supplies. So again, the difference between view and materialized view is that the result of the query will get stored in the table or a disk. Moving on, so this is our output here. If there are more than 20 rows available, it shows accordingly. Our next question, create a view v3 with customer name, order ID, and order date from v1 and v2. Our syntax is to create or replace view v3 as select v1 dot customer name, v1 dot order ID, v2 dot order ID from v1 v2. So what this does, it creates a view called view v3 with rows as customer name, order ID, and order date from the views we have created before. namely V1 and V2. So as you can see here, this is our output, and it elicits um, rows from views which were previously created. Materialized view would have create materialized view v33 build immediate refresh force on demand as select v1 customer underscore name v1 dot order underscore id v2 dot order underscore date from v1 v2. Yep, so that's that, and our output is as shown here. Our fourth question is to insert a row into the above table, and is the view updatable? If yes, if the updation reflected in the base table? Yeah, so our in order to insert a row into the above table, we um, we follow this syntax here. Create materialized view sample1 for update as select style from customer. So this would basically add a row to the table here, this table here. Yeah, so that's an example of our syntax, and as you can see, a row was added here. And as per the question here, we're asked if the view is updatable, and if yes, is the updation reflected in the base table? Our answer is no, it is not reflected in the base table, as the customer, it doesn't show our added updated row in the customer table, the main table. Question 5. Delete a row from the above view and state what happens to the other views from which it was created. So to delete a row from a view, namely the above view, our syntax is delete from the view name, which is sample1, where customer ID is equal to 05. So we go to customer, actually sample1, where customer ID is 05. So we look for customer ID is equal to 05, and we delete that row. Moving on to question 6, we are told to create a bitmap index on gender field of the supplier table. A bitmap index is a special type of index that is primarily used in the Oracle database, and the bitmap indexes are meant to be used on low cardinality columns. By low cardinality, I mean it just means that the column has relatively few unique values. For example, male, if you were about to do the gender, describe the gender, there are only two categories, male and female. As the two possible values considered low cardinality because there are only two unique possibilities that fit in that column. So here, as we create our bitmap index on the gender field, our syntax is create index gen underscore idx on supplier's gender, and shows the index created. Our question 7 is to create a B-tree index on the quantity attribute of order line table and evaluate the performance. Create index on order quantity or order quantity underscore quantity, and it will show the index created. Lastly, we are told to create a sequence in the order ID of the order table. Sequence is user-defined schema-bound object that generates a sequence of numeric values according to the specification with which the sequence was created. So to create a sequence here, our syntax is create sequence IDO underscore C, SEQ, increment by 1, start with 100, max value 200, no cycle, no cache. So that would create a sequence in the order ID of the order table. And as you can see here, our output says that the sequence was created, and thus that concludes our sixth experiment. Thank you.